All right, thanks, folks. Thanks so much for being here. I know that it means that you're spending time that you could otherwise spend, with your families or people you like better than us. That would be hard to imagine, but I think it's true. No, we really appreciate you. I know that it's effort and time and dime, and yeah, give me a little finger wave if you're ready to have fun talking about ransomware. Oh yeah, okay, cool.
Let's do this.
We are on native land here. We are on Massachusetts, Nipmuc, Mashpee, and Wampanoag land, among others. So I just want to acknowledge that. My name is Merritt Bear. I work in the office of the CISO, the Chief Information Security Officer here at AWS, Amazon Web Services. You probably know that because you're here. But I'm really happy to welcome you. I'm going to be talking a little bit about how we see things as a security shop that runs on AWS, and also about lessons that we have learned as we help customers secure themselves. Meg.
Awesome. Hey, everybody. My name is Megan O'Neill. I'm a Principal Security Specialist Solutions Architect. My focus is on threat detection and incident response. I've actually been focused for the last year and a half on ransomware. So I've spoken with over 70 customers at this point. And I feel like it's important to take some of those conversations, some of that guidance, some of their concerns, and actually get it out and be transparent with all of our customers. So we are working on a couple things. We have a public website coming that actually focuses on guidance. Instead of having to Google all the things on all of our different documentation pages and figure out things like, how do you protect S3? How do you protect RDS? What are the specific things you can do that are effective? So that's coming. I'm excited about that. But yeah, my goal, so I actually work with customers across North America, commercial customers, and have really been focused on ransomware. So our goal today is to get you to the point where you feel confident in the protections and controls you can put in place, what you need to be doing, eat your security vegetables, so to speak, so that you feel like you don't need to pay a ransom if something were to happen to you from a security event perspective. Awesome.
We're the begrudging ransomware queens. If you want to be queen of terrible stuff. No, but I think it's worth talking about all the stuff that we already know that you should be doing. And I will say, as just context, that what we cover today is not the start and end of it. As you all probably know, there's no one-stop shop for ransomware protection, and a lot of it is involved at every stage of your security grown-upness. And so there's sweetness to be gotten in a lot of different stages. We're gonna start in each of these at the more tactical layer and then get into the more strategic and kind of broad layers. And here we are. So this is our agenda for today. We're gonna kind of quickly get into why we're still dealing with ransomware. Thinking through some identity considerations, and then how we govern down. So why are we still here? Ransomware started in 1989, or at least that's the first documented instance. There was a health conference, it was an AIDS conference, where a guy handed out floppy disks that people then inserted that would crypto lock your device and then demanded a ransom. It was from a known cipher suite at the time, so he could have looked it up anyway. And it would demand a payment of $189 to a PO box in Panama. So I guess this is all to say that this is kind of nothing new, right? We've been here. These are very rarely 0 days. They're mostly folks who are getting in through stuff that you can secure and should, and we want to enable you to do that. So the first one we want to talk to you about is boundaries.
Yeah. So depending on where you are in your AWS journey, you might have deployed your environment within AWS 10 years ago. You might have put all of your AWS resources in the same AWS account and then been stuck in, how do I do least privilege access in one account when I've got multiple applications, multiple developers trying to deploy and manage their systems and not delete each other's resources. Over the last 5 years, we've started getting really prescriptive with customers. We're now telling you, we started telling you, go multi-account. Map your AWS applications to their own account, because the account is a security boundary. It is the ultimate security boundary that prevents lateral movement. So when you think of a security event in your AWS account, you really want to map it to that application. So use things like AWS organizations, OUs, to map common applications from a services perspective. So if you have a set of EC2, RDS, ALB, load balancers, that type of thing, you can put those in the same OU. You probably don't want to mix workforce enablement type tools like AWS Workspaces into the same accounts that you're running your front-end retail web application. You can use service control policies, SCPs, to specify what services should be allowed or denied at the AWS account within organizations at the OU level. The other thing folks use SCPs for is preventing or limiting to specific regions. So if you're not limiting regions in something like a service control policies, what do you need to do? You need to run guard duty across all regions, because how else would you monitor if something nefarious were to happen in another AWS account? So you can run guard duty, or you can block the regions at a specific service control policy level. The other thing, the last use case for service control policies is actually to prevent specific security controls and configuration from getting disabled. So things like CloudTrail that we want in every account, no matter what. Once it's been configured, we don't want someone to change that configuration or delete it. Guard duty is another common one. You know, you've got your guard duty, threat detection, threat management. You don't want someone going in and changing that configuration. AWS config is another common one. So really utilize those service control policies to put those guardrails in at the highest level. These are things that when you create an AWS account, when you vend an account from something like Control Tower, you've got those configurations in place, then you move it into that OU so that those things cannot be changed. So highly recommend setting that up as a best practice. The next thing I see, and this is, if you're a security, who is the security practitioner in here? Raise your hand. Awesome, very cool. I mean, I figured most of you would be, right? Reinforce. But anyways, so if you have a security event happen on an EC2 instance, for example, you don't want to question, was it public, was it private? Did I have a NACL in place? Am I monitoring for risky security groups? Do I even have guard duty enabled? Do I have something like a DNS firewall enabled? Do I have any additional security controls at the VPC layer? So what we recommend is to actually have a common VPC deployment throughout all your AWS accounts. Solve for the 80% of use cases when it comes to the systems that need to run in AWS, and build that VPC to support that. And then if you have a couple one-offs, it's gonna be a few one-offs, like 5 accounts. It's not gonna be thousands of accounts or hundreds of accounts, which most customers have at this point. So if you do have a security event in your account, you know you can reason about the security controls within your VPC. DNS firewall. This is actually amazing, and it's one of the most underrated features that has been released in the last year at AWS. Anyone familiar with DNS firewall? Right? Okay, like 2 of you. So, most recently we announced managed rules. So what does this mean? This actually means that you can firewall all your DNS requests from your VPC. So the .2 resolver, if you're using AWS DNS within your VPCs, you can actually set a firewall around that. And the managed rules are gonna look at common malware domains, domains that host command and control. And so that's just low-hanging fruit that you can block out of the gate. This is a managed service. You don't have to deploy anything. You check a box. You create a set of managed rules, and you can deploy those through Firewall Manager from a centralized perspective. These are tactical things you can do that are extremely effective at blocking the known knowns. So highly recommend checking this out and at least deploying managed rules in your environment.
Meg out here with the tactical good stuff. I want to talk a little bit about some of the requests that I get. Some of them are around like, can we get your threat indicators as Amazon, as AWS? And the answer is you are. It's guard duty, right? Like when we talk about those firewall managed rules, I mean, When folks play DDoS in our backyard, we track them and we take down the C2s. And we do, like a lot of this then turns into the goodness that you inherit, both in the bottom layers of the stack, the stuff that we are managing. Like, who here is worried about AWS getting DDoSed? Okay. There was a clearing of the throat. I don't think there was any hands. Like we do this for ourselves and we aren't perfect, but we're really good. And we work really hard at it. And we then externalize that to you. And so some of this takes the form of productization. And I think it's really helpful for folks to get a little bit of a lens into how we as AWS Security think about these problems and how we solve them, and then how it externalizes to you, because I think it may not always be obvious. So as I mentioned, guard duty has indicators. When the internet is waking up to something, we are 24/7. The indicators are already in guard duty. You are inheriting those. They will show up in your dashboard. Like this is the managedness of your cloudiness. Like you will have the bottom layers that we have already taken care of, but you will also have the stuff that shows up to you. And this matters because what you might have otherwise had to worry about manually is now taken care of. The best threat detection is the detection you don't have to do. It just shows up for you, right? And there are ransomware specific indicators in here. There's, crypto mining and lots of other good, bad stuff. But like, this is a philosophy that we believe in, that we are giving you what we have. Zero trust has been a really common phrase lately, and I kind of hate it. Yeah, see a few nods. Good. All right, my people. Because I guess okay, this water bottle is zero trust. Nothing comes in or out. Like, what can I do with that, right? I'm not going to do business. Nothing gets done. Like, we got to deal with the world as it is. And a lot of that entails doing work in the messy space that is, figuring out permissioning, figuring out boundaries, figuring out, all the stuff we're talking about today. So what I think we have decided is a useful framework to think about zero trust is to understand that it is a conceptual framework that that in the olden days, like 10 years ago, we might have accepted that anything that was inside the periphery was trusted. And so everything could move laterally and, what's the other? Up and down? I mean, it could move anywhere, right? And that the idea is that we are now thinking about it in more dynamic terms and also more structured terms. So let's zoom in. When we talk about zero trust, are we talking about the network? Are we talking about perimeters or maybe micro perimeters? Are we talking about security above the network? Gateways, proxies, VPNs, combinations? I thought it was kind of creative that I put a honeycomb for a network. Or are we talking about identity, right? Are we talking about the ways that you authenticate? Are we talking about humans when we talk about identity? Are we talking about machines? Are we talking about software, talking to software, or maybe a combination of these, right? And I think the way that we have constructed this to be a useful concept, and the reason that I bring it up in a ransomware talk, is that this should not be a binary choice. And I don't mean binary like zeros and ones that we write in code. I mean binary like one or the other. We should be not only embracing both these, but allowing them to speak to each other and complement and augment one another and be aware. And we can do this, right? So we're talking about something that is, the perimeter is dead, long live the perimeter, right? There are uses and important elements of a VPN or a VPC. And then we build on top of that and have fine-grained identity-centric controls and, access attribute-based access control is the standard now. And so we're talking about things that you can then codify in these policies that we've kind of alluded to, but we can talk about more, where we're, one example of this might be a VPC endpoint policy. Who knows who this is? I know, it's hard. Old white men look a lot alike. It's not Confucius. I already told you he was white. It's Euclid, because this goes at least as far back as Euclidean mathematics. Because the idea is that we don't go out and try to count every prime number. We accept the infinitude of primes to be true, right? And in the same space, we think that if you can reason about something, if you can mathematically prove something, then we believe that that is provable security. So we have a whole group here at AWS called the Automated Reasoning Group, ARG, and it's a bunch of math PhDs that do higher level reasoning about the security of stuff. And on our side, because I'm kind of like talking both to the shared responsibility model side of ours, we use this to prove that our boot code is correct and our crypto is correct. Like, we use it internally. And on your side, you will feel it but not touch or see it in the form of things like Access Analyzer that can reason about your permissioning and prune them down. Escalation paths, possibilities of escalating permissions. As Meg said, no stars in your policies, right? I mean, computers are better at reasoning things that can be proven. And as we know, some of this is better read by computers. Another one is an inspector, so network reachability, right? Without sending a single packet over the network, we can show whether you have an internet-facing endpoint or not. And this is important for compliance, but it's also important for just like knowing where you are. And so this is really an interesting element. It's not that this is everywhere because it has to be a provable space, but it's more like an element of cloudiness that matters here. And that, as I mentioned with our productization, this is like an inheritance that we believe should come with every product. We do not ship things until they go through a rigorous security review. And that is a fact. I mean, it is important that Steve Schmidt, my boss, reports to the CEO. No one can outclass him. No one gets to say, no, we're gonna make a bunch of money, like, let's ship this anyway. It never happens. And that is a design decision in itself, right? And there is no button on KMS that says, vend me the plain text keys. And that is a decision. We built it. We can't see it. Think about Nitro, or under the hood of every EC2 instance. Again, no human access. So these are availability and other like beauties that you inherit, but security is an inheritance of that.
Awesome. All right. This would not be a ransomware talk if we didn't double down on identity. So the most common issue we see when there are non-traditional ransomware events on AWS is leaked static access keys. So if there's many call to actions in this talk, but the number one I want you to take home is see how you can eliminate long-term credentials. Go through, perform an audit of what's out there, set up federation.
Can I get a quick?
Yeah. Thank you. If you don't have federation set up, set it up. That's where you want your developers to be accessing AWS through a federated access. Don't create another IDP on AWS if you have one already. Like, it's a lot of work to do that. You don't need to do that. Set up that federation. Make sure your developers are using the latest version of that CLI, which integrates directly with AWS SSO, which is now Identity Center. And that way, you're not storing static access keys on their laptops anymore. They're not accidentally checking them into a repository. This happens, right? This happens. We see customers struggle with this. I don't want you guys to struggle with this. So get that federation set up. Restrict the creation of static users to probably your security team or your CCOE team. Don't allow developers to create static IAM users. They might not know that that best practice is to use IAM roles. But if it takes them actually having to request it through the security team to make sure that full feedback loop of what are best practices in AWS, say they're brand new to your company and they're brand new to AWS, they might not know this. This is a way to make sure that they get educated from you, right? So make sure you've restricted that permission so that these things can't pop up in your AWS accounts without you knowing about them. And then I mentioned audit and track. What are we talking about here? Go through your AWS accounts. Take an inventory of what's out there. Know how many static access keys you have. know when they were rotated last, and ask yourself the 5 whys. Can we re-architect? Did anybody see the announcement last week that IAM roles anywhere is a new feature within identity? That's amazing. Given IAM roles anywhere, which allows you to actually bootstrap something like a server in your data center to use an IAM role now as opposed to a static access key to perform non-interactive access within AWS. I haven't heard of a use case where static access keys are still required. If you have one, find me afterwards. I want to know, because again, we need to eliminate this. If you can eliminate this, you can reduce the risk of a non-traditional ransomware event in your AWS account. And that's huge. That's what we're here for today, right? So ask yourself if you can re-architect. One of the common things I see customers struggle with is something like, hey, we have a Jenkins machine on-prem that does all our deployments, on-prem and AWS. You can run Jenkins in AWS. You can use an instance profile as that system boots up with the access it needs. Instance profiles are all short-term static access keys under the covers. You don't need to give a static access key to a Jenkins machine on-prem with ***. It's probably running a very permissive policy so that it can deploy whatever it needs to, right? Build that machine in AWS, use an instance profile. The worker nodes that actually build and do your deployments across your accounts can use their own instance profiles. So at least move to instance profiles for things like that. You can re-architect. There's actually great guidance out there. Just don't do your default Jenkins configuration. We've all heard those stories as well. Get those keys rotated to at least reduce the risk of an old static access key coming out. There's actually Git secrets, which is available in our AWS GitHub that you can pull down and have your developers use to kind of scan for secrets as well if you're trying to make this transition. And then in those IAM policies, for the static access keys you have left, do you have wildcards in there? A wildcard, right, is going to be, you can use it as a service, as an action, or a resource. And the challenge here, the call to action, is make sure that those wildcards don't exist in those policies at all. So you have to specify the service, specify the action, and specify the resource. And I would take it one step further, that if you are on your path to eliminating long-term access keys and you still have several of them, remove any delete permissions. Because what we're seeing with non-traditional ransomware is not someone taking a KMS key in another AWS account and encrypting your data in S3 with it. It's them actually deleting the data and then saying, hey, we have it, give us, a Bitcoin, whatever, multiple Bitcoins. So if there's no delete access for those static access keys, then
these days they're going to need more than one. Have you seen the state of Bitcoin?
So getting rid of the delete permissions for those static access keys is going to also help reduce the risk until you can fully eliminate them, right? Because this is a journey. I started my customer experience on AWS back in 2014, and we learned so much. And we redid the environment a couple times, and we aligned with prescriptive guidance, and there was always something to learn. So I know it's not going to be perfect. There's a journey to eliminating these things. But with IAM roles anywhere, so let's dig into that a little bit. What it requires is that you have some PKI infrastructure that you can trust. You can build the IAM roles anywhere, IAM role, and then bootstrap it on your server with something like a credential helper that we have available. So super exciting that that's now there. Again, if you have a use case that I haven't thought of or, that still makes sense to use in the environment, let me know. So we talked about IAM roles anywhere. Okay, so what are some of the tools out there that can help you with risky configuration when it comes to identity? Is everybody familiar with Security Hub? I find this is another very underrated service that a lot of customers aren't aware of. This is our cloud security posture management service. And so what we do is we provide you a single pane of glass to look at all of your AWS security findings. And this is most of the AWS security services. This is GuardDuty, Access Analyzer, Macie, Firewall Manager, automatically send their feeds to both Security Hub, and then Security Hub forwards them to CloudWatch events. So if you're trying to integrate with a downstream SIEM, security information event management tool, it should be from Security Hub so that you don't have to bootstrap it to all the different services, because we're doing it for you with Security Hub. If it doesn't integrate with Security Hub, like Shield, for example, it's on the roadmap to get integrated. So this is the service you want to focus on. Security Hub has a set of security standards checks and compliance checks. So today we have the CIS Foundations benchmark by the Center for Internet Security. This is looking at the configuration of your AWS account. Are you mapped to best practices from a security perspective? We also have PCI DSS, and we've got the AWS Security Foundational Best Practices. Security Foundational Best Practices security standard is curated by the internal security community at AWS. So you can bet that there's a lot of rigor that goes into those checks. And we're not just looking at the AWS account specifically, we're looking at all the AWS services. And if it's not covered, it's on the roadmap. So these are things like, are you following security best practices for Redshift? Are you following security best practices for RDS, for S3, for EC2, for your VPC? Do you have the default VPC security group there, right? So let us help you with that, because it's tough to keep following on all of the AWS announcements and changes. So we're continuing to curate this list for you over time. So highly recommend there. If you're brand new to Security Hub and you want to turn on these security standards, start with CIS and then progress into Security Foundational Best Practices, because you're talking about like 50 checks versus 150 plus, right? So get CIS version cleaned up and then advance
that dance
into
move once more, Meg.
Yeah, I can entertain y'all. So some of the things you would find specifically for the foundational security best practices in Security Hub for identity are some of these checks. So the high risk ones, we're talking about, hey, look, there's a wildcard. IAM policy should not allow wildcards, star, because that provides full administrative privileges. So if you're asking yourselves, gosh, how many policies do we have that are actually wildcarded? Let foundational security best practices find them for you in Security Hub. IAM root user access keys should not exist. If this shows up in your account, get rid of those access keys. Well, first do an audit, make sure no one's actually using them. Guard duty will tell you that as well. And pull them out. Add MFA. It's another check in there. This is really helpful. So we're trying to make some of this data available to you so that it's not a surprise. All right, so I talked to a lot of customers that have struggled with identity. It is one of the most complex services in AWS. That's a good thing because it allows you to get really granular with fine-grained access control policies. But it can also be really tough when it comes to providing your developers that balance of what can I do, how can I be enabled and deploy what I need from a applications and feature standpoint to support my business versus least privilege access in AWS. So again, I mentioned SSO. Set up federation, whether you have an existing or a third party like an Okta, get the federation set up for your developers. That's the best place to start. Develop a set of permission sets that are custom to what those developers need. But that is where you should spend most of that time on what does that developer policy look like. They probably don't need access to what? Create IAM users. They probably don't need access to change the VPC itself, like attach an internet gateway, right? So lock them out of those things where your CCOE or your security team should be involved in those decisions. If you've got a VPC deployment that you're happy with, that we talked about earlier, that solves 80% of the use cases, why are they attaching an internet gateway to a private subnet? That could be a problem, right? So those are conversations that need to be had. So highly recommend that. Get those service control policies set up. You want to have an allow or a deny list of which AWS services should be used at the OU level. You want to block out specific security configurations that were put in place when the account was vended that should not be disabled. CloudTrail, guard duty, config. You want to restrict region usage. And if you're not confident enough to restrict region usage, because it can be kind of scary, enable guard duty everywhere so that you're at least monitoring. Guard duty is a service that's going to charge based on the activity that's happening. So if there's no activity in those other regions, that spend should be very small. But if there suddenly is, you want to know about it. And then utilize permissions boundaries. I'm actually surprised most of the conversations I have with customers, folks have never heard of permissions boundaries. Anybody never heard of permissions boundaries before? Okay, good. Yeah. Okay, permissions boundaries give you the capability to allow your developers to create their own IAM roles and policies without escalating their own privileges. So you can apply a permissions boundary policy that limits the policies your developers create to do things like change VPC, create IAM user. So it essentially prevents elevation of privilege, right? But allows developers to still self-service their policies. And super valuable service. It's very underrated. I want to make sure and bring it up for you guys so you were aware of it. All right, what about the process and people version of trying to actually change your identity strategy? This is tough. And I talked to a lot of customers about this. What I recommend is that they develop a CI/CD pipeline so that when they need to change an identity policy and the security team is reviewed or your CCOE team has reviewed it, it can happen very quickly to all of your AWS accounts. There are so many tools within AWS that can help you do this from an automation perspective. Code pipeline, code deploy, CloudFormation. There's open source solutions out there that do this for you. If you're using permission sets, those are replicated for you. If you're using managed policies, you can do this in CloudFormation. So the other thing is to allow developers to self-service this request. So when they have a pull request, they actually put the business justification. Why am I asking for this access? That should be a business justification. If it's not, that's where the redo and the pushback, try again, you know. But if they have a good business justification, your security team can see it, it makes sense, then you approve and boom, those policies are deployed, right? We're not trying to slow developers down, but we need to give them some boundaries to operate within. The other thing is that, as I mentioned, identity is one of the most complex services in AWS. It's not always the organization's identity team that can immediately jump in and understand IAM policies. It might be your CCOE team. It might be the team that initially created the AWS accounts. So have that team help the identity team and come together and help them understand what these policies mean so that they understand what they're approving. That's going to be much more successful than throwing this over the wall to a security team that's never seen an IAM permissions policy before, right? And the other thing is educating and supporting your developers. So one of the things I can't emphasize enough is that if you give your developers, whether you're starting with a checklist or you're codifying policies, what you expect them to build from a security perspective, they'll want to build towards that. But if it's just in some security person's head and they don't know, then you're gonna get a lot of weird stuff coming out of the other end of that pipeline. So at least give them a checklist. From an identity perspective, what do you expect them to build? What is secure? They might not know AWS when they join your company, so it gives them a starting point of expectations. No static IAM users. Use IAM roles for system-to-system access in AWS. What does a least privileged policy look like? No wildcards. You can start there. There's low-hanging fruit that you can do just an educational perspective to get everybody on the right page so that they can be successful from the start. And you don't have to be the team of, oh, we got to go clean all this up later. You know, you might have a little bit to clean up, a little bit of automation to throw in there, but hopefully it won't end up being this giant onion you need to peel back.
Yeah, Meg, killing it. Thanks, folks, sticking with us here. We're going to talk a little more about how we think about governance and guardrails, both on the product side and how we do it internally. So at AWS, we made an intentional decision that we're going to be very permissive. So we let folks do a lot. But that means that on the other side, we do a lot of logging and monitoring. And, you know, in the cloud, there is a lot of logging and monitoring available, right? Everything is an API call. You can be watching your CloudTrail logs for those. Every KMS call is, I mean, sometimes hundreds of thousands at scale, right? And then in your CloudWatch, we're talking about CPU usage and other things, like everything is logged. You're not going to get into the host, that's on our side, which is a boon to you. You know, like these are beauties, but we got to think about how we then take those metrics and turn them into governance and ways that we make paved roads. We have a phrase here that is to make the secure thing to do the easy thing to do. And that is hard. Because as Meg said, like, we don't want to get in folks' way. Maybe you haven't noticed, but we deliver tech products. So, you know what I mean? Like, we are not here to get in the way. And in fact, like, if we are in the way, that is a problem. That being said, we have the wherewithal to put stuff around that allows us to minimize snowflakes, to ensure that nothing gets deployed without a security review. You know, there's a lot of beauty in this, but it's hard. And the beauty comes from the replicability and the ability to take advantage of cloud scale, right? So we're talking about templatization, embracing vending identity accounts, vending architectural templates, coming back to a golden AMI. Like these are things, we know this much is true. Here are some of the ways that you can deploy them yourself in terms of, so Meg described AWS organizations, which is our kind of like governance umbrella. And he thinks he can walk away without me making a comment. No, I'm just fine, whatever, sir. You don't need this. Okay, so organizations is how you will manage those thousands of accounts at scale, hundreds, tens, whatever, like the way to scale up your governance, right? And within organizations, you're going to deploy SCP, service control policies, and some of those can even have security prescriptiveness embedded in them. So this is an example. This is S3 block public access, which you can turn on. The next one is S3 default encryption. Block public access refers to internet facing, right? Which folks should be taking advantage of. Like, this is critical. Turn on block public access. You will get a finding when you know, like it can't happen if you put an SCP. And if you get baselining that shows anomalies, you will then see it. You know, like there are all these ways that we are helping you prescribe things that help you improve your security posture. So this is default encryption. Like you simply cannot spin up something that is not default encrypted. EBS default encryption. And this one is CloudTrail enabled and an SCP to prevent deletion. As Meg mentioned, you know, delete calls are one of the ways that we sometimes see folks coming in to do bad actions. Like put an SCP on. Here's another example, and I think, you know, we've referred to this a little bit, but we joke, but not really, that in AWS security, we like to hire lazy security engineers. We want them to never solve the same problem twice. Codify it away, if it can be codified, right? So this is an example of a CloudFormation Guard 2.0 rule, and this will say that, you know, it's both doing policy as code and enabling security to be done in the prescriptiveness. So if elastic load balancers are present, ensure that they have protocols specified from the allow list and the certificates are not empty. Those are security inheritances, as you know, but like you can prescribe that and you can prescribe that. SCPs, so here's another example. Prevent any VPC that doesn't already have direct internet access. So we're not breaking your systems. If you already have it, maybe it's legit, but no new ones will get it. This is where I talk a little bit about our culture of trouble ticketing. We rely heavily on trouble ticketing. Does anyone here use trouble tickets? Yeah. It's the worst system except for all the others, right? Like what's the alternative? An email? So I think the point here is two things. One, we can authenticate folks in an identity sense. So like when you have submitted a trouble ticket, you already have verified who you are in some sense because you've gone through the protocols that we've already prescribed, that paved road. Because you've already VPN'd and you've already, you know, like we know a little bit about you. And two, increasingly we expect robots to resolve them. So like I was saying, the codifying away. When someone puts in for access, the robot, well, the automation can sense whether it was granted and then resolve it automatically. And as a fun side benefit, you will retain your security engineers because they will not be bored doing manual processes that they hate. One of the big questions I get is like, how do I create a culture of security? You get it by doing it. sort of like creating a culture of diversity. You just do it. But it's better done with mechanisms because good intentions are not enough. If it's not someone's job, it's a hope, and a hope is not a plan. So one of the ways that we mechanize this, I already mentioned that, Steve reports directly to the CEO. I think that's important. Like mechanisms that allow for 100% of security executives will say they care about security. So what? How do we mechanize that, right? And one of the ways that we mechanize this internally is in the trouble ticketing system. It's kind of a tongue twister, it turns out. Mm-hmm. Everyone say trouble ticketing system 3 times fast. Mm-hmm. And we have a belief culturally that you should always submit a ticket if you're not sure. And if you're not sure it's a Sev 2, it's a Sev 2. Let us be the show don't tell. Like, we will tell you if it isn't, and that's fine. But that also means that our executives get paged. It means that every VP knows that they need to answer the phone in the middle of the night sometimes. Things get automatically and blamelessly escalated. That's an affirmative decision. And every VP, there are no, I think, Amazon employees in the audience, but if there were, I would say, who has had their manager page? And it would be everyone. Yeah, exactly. Because we play around in that environment I described, and because we run into guardrails and then we hit Sev 2s sometimes. Hopefully they're not Sev 2s, but let us be the arbiters of that. And the point is to create a culture where you can tell us anything, and please do. And that is a cultural decision in the form of a mechanism that I encourage you to adopt. All right, well, this was, I was looking up images that have no gray area, and this chameleon apparently does not. I kind of just like it. But the point is, right, do not shake your head. It's a good one. The point is that, as we think through these automations, so all of these are lambdas under the hood, right? We're talking about config rules, CloudWatch Event Bridge, or raw lambdas that you're writing to be able to automatically remediate. I was thinking through those controls. We're talking about protective, the things you will never let happen. Preventive is another word for that. Descriptive and logging and monitoring ones. And then the remediative. Now I'm on the remediative. So we're talking about the things that you are putting automations against so that you come back to an own good state. And these are, like I said, super easy to write. Does anyone have an Alexa or an Echo or whatever, Google, whatever, in their house? You can write these as raw functions. I encourage you to let your 6-year-old, if you have one in your house, write one. Because they're super easy to write. They're raw functions. And the point is that you can do them really lightweight, really simplistically, but you need to make decisions. You need to do some thresholding. So folks often are like, I don't know where to start. Well, don't you know that there are some things you will always allow and some things you will never? Let's start at those. And then just scope down that gray area of human decision making so that we're really talking about the truly unique or high stakes situations. Again, as a fun side benefit, this will take advantage of your smart humans doing smart human things, which will help you attract and retain talent. You will want folks who live in this world. Yes, this is one of my 3 brothers and me in Colorado in the snow. But the point is, as Meg has already described, this is not a static thing. You will continue to improve upon these. Brandwine said to me, our VP, kind of like the Yoda of AWS Security, said at one point, I have never built anything beautiful. I just started somewhere. Solve big problems by solving small problems. Layer those sands on top of them. The best time to start was yesterday, the second best time is today, and the next is tomorrow. Just start doing it somewhere, and you will build on those, you will refine them. And as we have described, you can templatize, so you refine those and then are able to inherit the benefits going forward.
Awesome. Notice this slide does not say DR. It does not say backups. It says application resilience. So when it comes to a ransomware event, to feel confident enough to do something like, oh, we don't need to pay that ransom, we got this, you actually have to go through and rehydrate your data and bring your systems up, usually in another AWS account. That's going to be the fastest approach. So what does that actually look like? Well, we've had several large customers come to us and say, hey, we used to have tape backups. How can we take an immutable approach? How do we do this on AWS, right? And what this looks like is, I mentioned at the beginning of this talk, the AWS account itself is a security boundary, and the organization is a security boundary. So some of our very, very large customers actually have multiple organizations, and they build this in a separate organization. If you're not at the point where you want multiple organizations, you can build this in a separate OU structure in that organization, but it's all separate accounts. We have 4 accounts here. We have our staging account. The staging account pulls your backup data from wherever you need to. Could be other AWS accounts, could be on-prem, could be third-party cloud providers. And then we've got this Vault account. The Vault account is set up with automation that pulls in your backups from the staging account. It's a known location, usually an S3 bucket. That doesn't change. That automation is set it and forget it. Maybe you have a subset of users logging in through Federation that could change this, but not necessarily anyone else in the account. So you can really specify from an account boundary, organizational unit, SCPs, which services should be running, who should have access that's separate than your standard applications running in AWS accounts. You probably have S3 object lock, which is worm, so write once, read many, enabled on your Vault account, preventing anyone from accidentally or maliciously deleting objects. End of story. Versioning is required to enable object lock. You can do fancy things like apply a retention period. So, hey, this data can't be touched within 5 years. You can do things like governance mode, where it requires special permissions to actually change the policy. And then you've got your Vault Forensics account. This is your security team. Maybe they have a set of security services or EC2 instance with forensics they want installed, but maybe it's shut down, so it's not running 24/7. So that if you need to go and look at the data that's in your Vault account and determine how far back you need to go from a restore perspective, they can spin that system up, look at the data, and help you determine that, right? And then you've got this recovery account. You can have that recovery account sitting there for 2 purposes. One, if you actually need it in a disaster recovery actual scenario, such as like a ransomware event. 2, for your exercises. Because what I want you guys to do as a call to action is to actually go through a full disaster recovery exercise and get the systems up and running. This is different than what we used to do on-prem. I've been involved in many disaster recovery exercises back in the day. It's a little different in cloud in that you learn a lot of things the first time you do this exercise, and it really changes the way you operate. One of the first things is, I've seen application teams from manually building resources to all of a sudden being like, we're gonna rebuild this whole thing in CloudFormation. It's not that hard. It seems hard if you've never played with CloudFormation. It's a YAML. You can do it. I can do it, you can do it, right? Because if you're building an application, there's several things besides just the EC2 instances in the data store. It's the IAM roles, it's the security groups, what subnets you're deployed in, right? And you can parameterize these templates so that you can just deploy them as your dev environment, deploy them as your production, deploy them as your DR. And all of a sudden, you don't have to manually track changes to the IAM roles across 3 different AWS accounts. So this is like a game changer. If you actually go through this process and restore your systems and do this exercise on a common basis, you're gonna learn so much. That's gonna be a huge difference between getting back up and operating in 5 minutes versus 5 weeks. And also having the confidence to say, if you have a security event, just restore the systems and move on, because you've done it before, right?
One of my favorite quotes from Beetle is, there are 2 ways to learn incident response, and one will be chosen for you.
Another thing I want to talk about is using data and database services. We have additional features and functionalities that are helpful, that prevent things like accidental deletion. So I talked about object lock. We haven't talked about vault lock. The capabilities of Worm, write once, read many, are available for both Glacier and S3. Versioning is required. You can pick the governance or retention mode that I talked about. Those are available. Point-in-time recovery for DynamoDB. Let's take a step back. When you think about using a managed service by AWS, some of those security beauties that Merritt talked about that you inherit from us is we don't expose the operating system. So when we think about traditional ransomware on AWS, it's actually, I haven't seen a lot of it. I'm not saying it's not possible. If you've got like a flat AD domain and you're connected hybrid and there's nothing in between there, it's certainly possible. However, it's not what we're seeing as common. So utilizing our data stores that are managed means we're patching for you. We're maintaining that host. We're restricting who can access those underlying systems for you. So that's just a beauty you enable, right? Point-in-time recovery is an additional feature you can run on top of DynamoDB, and there's other databases that support it as well. You can literally rewind per second anytime within the previous 35 days. So if someone accidentally deletes something, you can just point-in-time recover. And it requires no performance impact on your system because we're doing it on a different system on the side.
Meg, you should have had a picture of the DeLorean here.
Oh, totally.
Time machine.
Time machine. Point-in-time recovery. Think of it as a time machine for your databases. And of course, it comes at a cost. So you might not necessarily want to deploy this to every single DynamoDB instance you have. But for the most critical ones, absolutely, it makes sense, right? Elastic disaster recovery used to be considered Cloud Endure, right? This is actually a really cool service. So if you have a heavy deployment of EC2 instances, if you want to run this on-prem and restore to AWS, a lot of cool capabilities here from the infrastructure perspective. So take a look at that as well. I also want to bring up AWS Backup. AWS Backup supports several data stores and databases. Announced S3 support in February. It doesn't support cross-region yet for S3, but that's coming. That's a huge ask from customers. But they actually announced Vault Lock late last year. Vault Lock is the Worm, write once, read many capabilities. The other thing I like about AWS Backup is it's a separate access policy. So who should be maintaining your backup policies themselves? Probably not your application folks, maybe, but it could be a separate group of people. So you're separating the concerns from a permissions perspective. So think about that as well. And the call to action for this section is really practice the recovery. Do the full hydration. You're invariably going to run into issues like, hey, we forgot to copy that custom AMI over to our new account and share the AMI ID, right? But if you've already had a security event or any type of disaster in an old AWS account, maybe you don't want to do that anymore. Maybe you don't feel comfortable about the state of that AMI, right? So having these things all done ahead of time, using infrastructure as code and automation, scripting as much as possible, but actually doing the exercises to learn it and to build that muscle of recovery is going to provide so much confidence so that you don't have to pay any type of a ransom if that were to happen in your environment. Awesome. More sessions focused on ransomware that are available here for you guys. Definitely take a look. We've got some hands-on stuff. The builder sessions are hands-on where you can actually run through some scenarios. Pretty neat. But most of all, thank you so much for attending. We appreciate any feedback you have.
Folks.
Feel free to
Thank
email
you so
us.
much.
Emails are there.
We'll stick around for a minute or two. So if you want to come talk to us, we will be here. Thank you so much.
Thanks.